Good morning, guys. So this is our last lesson for this polynomial function unit. Everybody say yay! I know it's been quite a long unit, but we're finished it and we're going to move on after this week. So when we're looking at multi-step polynomial problems, these look probably more familiar to you than the stuff we did earlier in this unit. And you might find this a little bit easier because it puts a real world application on it where you can be like, hey, I could totally use that in my real life. So that's a good part of this lesson. So some of our key concepts are formulas can be used to solve multi-step problems that arise from real world applications. And when you start going through the different problems, you see that there are many occupations that require applications of polynomial functions in the real world. So it's not, I know a lot of this stuff seemed a little bit more graphical or theoretical, but people use these all the time. So let's look at an example, and I'll go through it, and then it'll be similar to what you'll do in the practice stuff. So let's check it out. Winston has decided to paint his living room. The length of the living room is 9 meters. Now, I like to highlight the key important stuff, so I'm going to highlight. It's 9 meters, the length. The width is 6 meters. And the height from floor to ceiling is 3 meters. So I'm going to keep that in mind. 9 is the length, 6 is the width, height is 3. So A says we're going to determine the surface area if he is going to use 2 coats of paint. So the first thing I'm going to do is solve for our surface area. Because we're using 2 coats of paint, I'm going to solve the surface area and then I'm going to times it by 2. So because we need those 2 coats. Now, the other thing you have to think about is when you're thinking about painting, what is it that you're going to paint in terms of the walls in the living room? We're obviously not going to paint the bottom, the floor, and we're obviously, I don't think this is going to paint the ceiling because it doesn't specifically say that we're going to paint the ceiling. So let's just assume, and I know it's not always good to assume, but we're going to assume that we're just painting the walls. Now, I've told you guys before, sometimes it's good to kind of draw it out or make a diagram. So we know that the living room has 4 walls. So I know that we have 2 walls that are 9 meters with a height of 3 meters. And I know that I have 2 times 6 meters by 3 meters. Now, you might be thinking, hey, Jen, if I put all these walls together, how are the people going to get in? Now, the nice thing about, in terms of like construction and stuff, it's okay to estimate more paint than what you think you're going to need. So in this case, I'm not going to worry about any possible windows or possible doors unless I want to be super duper accurate. But it's okay to get a little extra paint if you need a little extra paint. So I'm just going to calculate it as is and kind of ignore the fact that there's probably doors and possibly windows because it's not going to make too big of a difference. Okay, so I'm going to do the area of this, which is 3 by 9, so 27, and we have 2 of them. So 2 of them makes 54 meters squared for those 2 walls. And this one, I'm going to do the same thing. 6 by 3, which is 18. And then we'll times it by 2, so 36 meters squared. how many 4-liter cans of paint? So again, I'm going to highlight, there's 4-liter cans. 1 liter of paint will cover 12 meters squared. So let's go back to the first thing, our total area. If we add it all up, is 54 plus 36, which gives us 90 meters squared. So B says 1 liter of paint will cover 12 meters squared. Oh, hold on, I forgot one thing. That was for one coat. One coat. Let's do it for 2 coats, which is 180 meters squared. So B says 1 liter does 12 meters squared. So I'm just going to take my total area and divide it by 12. 180 divided by 12. Gives me 15 meters, or 15 cans. Sorry, guys. 15 liters. Now the question said, how many 4-liter cans of paint? So 15 liters, if we think about it, if we divide that by 4, it's 3 3/4, but I'm just going to round it up to 16 liters because I can, it's okay if we have to buy extra. So if we round up to 16 liters, that means we're going to need 4 cans. All right, so that's B. He's researched the internet, found a suitable paint that costs $30 for a 4-liter can. How much is the cost to do it? So again, we're going to take our 4 cans times $30 each. Means before tax, it's going to cost $120. What are some factors that Winston should consider before he makes his final decision on the amount of paint to purchase? Now, this is one thing you need to sort of think about. In this case, you could think about possible touch-ups. Are you going to need extra for that? Is 2 coats going to be enough? What else? What are factors that Winston should consider? So you can come up with some of your own possible reasons what else he needs to consider. Sometimes with these types of questions, especially with construction, is if you're looking at tiles, you might think, what about wastage? What if I have to cut a bunch? I know it doesn't really go with the paint, but stuff like that, you want to really think about. Yes, I might screw it up, so maybe I should get a little bit extra. And buying for exactly what you need is sometimes not enough. And so people will get a little bit extra if they need to. Again, it really depends on the person who's doing it. But all the questions that you're going to have are similar to this, and they kind of get you to think about it. Anyways, it's not too bad. I think you guys will find this lesson pretty easy. And then next week we're going to move on to something else. So I'll see you later, guys. Bye.